Okay, so I'll get started now. This slideshow, before I get into it, I just want a quick disclaimer about its content. So I'm not going to tell you how to write bash scripts exactly. There are lots of tutorials online to do that. What this really is about is just best practices for bash scripting that allow you to write safer and more robust scripts. So Bash is extremely powerful, but as a scripting language, there are many ways to do the same thing, some of which are better than others. And this can lead us into some tricky situations. Bash is deceptively simple. Essentially, scripts are just lines of multiple commands that you'd run in a terminal. But the real danger and power of Bash lies in its access to the file system. If you're not careful, you can inadvertently overwrite or remove the wrong files. So we should have two goals in mind for using Bash. We want to avoid disaster, and we want to be able to leverage this power to simplify our automations. So what are the safety rails that can help us satisfy those goals? Well, we have automated checkers that we can use, somewhat similar to what you'd have in an IDE for Python or Java. There are some best practices that we can follow. And of course, I can't really overstate the importance of manual testing. So I'll go through each of these safety rails and then also go over a few tips and tricks for some specific cases that I think are worthy of extra attention. So first, let's look at the best automated checker for shell scripts. It's called ShellCheck. I just added it to the shimming toolbox repo last week, and it's part of the Travis build. So what it essentially does is it covers both syntax and semantics. When you run it on a shell script, it gives this output on the right, pointing where exactly the problematic code is, how to fix it, and a link to a wiki page about that particular pitfall. So what I've done here for this screen cap is I just checked out Julian's branch about an example z-shimming bash script. And I just called ShellCheck with ShellCheck and then the name of the shell scripting file. And the output that it gives, it says, at line 12, there's this particular command, cd testing data, real-time z-shimming data, and it issues a warning saying you should actually write it this way: cd double bar exit or cd double pipe return in case cd fails. And it actually tells you exactly what you should put in for the command to make it safer. And it goes through each of the other warnings and links to these little codes that has the SC with a 4-digit number. It actually links to a wiki entry on ShellCheck's GitHub repo. And here's an excerpt from a wiki entry for a particular type of problematic shellcode. So it will tell you, what you might have with your problematic code and how to correct it. And if you were to scroll down further on the page, which is not in the screen cap, there are some other details about this pitfall. So moving on to best practices, I really like the Google Shell style guide. So Google, as a company, they write software in many different languages, and they have a style guide for pretty much every one of them. So there's one for shell scripting. The link is here, and all of my links are also at the end of this slideshow. So in their style guide, they have lots of tips that set good practices in stone for improving shell script quality and robustness. For example, for quoting, this is an excerpt from it. So always quote strings containing variables, command substitution, spaces, or shell meta characters. And and how to use arrays with quoting. Always use double quoting for variable expansion, etc. And to move on from best practices, always remember that you should do manual testing. And let's just quickly dip into some things to think about when testing manually. You should test your script with good input. You should test it with bad input. And in both of these cases, does the script behave as expected? Is the script success distinguishable from failure? Does it fail loudly? That is, will the user know when something went wrong, or will they continue on blissfully unaware that the script had failed? And does it succeed silently? Now, this is kind of not strictly necessary, but really you don't need a ton of output to the terminal to indicate that something went right. So now for the last part of this talk, I'll just go over some general tips and tricks. These aren't really comprehensive. I've just picked out a few that I think are really important to keep in your tool belt. So the first one, use the best shebang. This is a very common pitfall. It's very easy to fix though, and it definitely results in a lot more portability for your shell scripts, especially on macOS systems. So you might expect hashbang bin bash to point to bash, which is true on most Linux-based operating systems, but it usually does not point to what you probably intend for a bash executable on macOS systems. So instead it would actually point to the built-in bash, which is an older version, which has fewer features. So instead use the env command, which will call whichever bash executable is first in the path or aliased in the user system, and this will work on all POSIX systems. This is a really common pitfall, not using the correct brackets for conditionals. So using single bracket conditional tests. So just a quick background on how bash came to be. There used to be just sort of vanilla, for lack of a better term, shell scripting, which had a much smaller feature set than bash. And then at some point, bash was invented and had a bunch of features added on top of those vanilla shell scripts. And one of these old features were single brackets for these tests, so the condition for an if clause. And one really unexpected thing that you'd get from this, in here I have a command expansion inside this test. So ls is running. It's listing files that match this pattern and checking if it matches foo. So if for any reason ls were to fail, with single brackets, what actually happens is that the script continues to run. What's more is that because this errors out, the interpreter doesn't know what to do, and it actually continues executing commands inside the if clause, which you definitely don't want, especially in this case, you're removing a file. But if you were to use the bash feature of double brackets for conditionals, if ls were to fail for any reason, the interpreter stops right there. Nothing else gets run, and the actual script will be exited without running anything further. And yeah, that's definitely safer. And an error code, of course, will be thrown. So I just mentioned that we were doing some command substitution in those if clauses. When you're doing command substitution, don't use backticks. Use quotes and then $round brackets. It's easy to read, and you can nest these indefinitely without having to do any backslash escaping, unlike backticks. Speaking of double quoting, quote all your strings and double quote all strings containing variables. It's fairly self-explanatory. This is just one of the Shimming Toolbox CLI examples that I pulled from that branch that I checked out. So this is what it would look like. This is what it currently looks like. This is what it should look like. If you run that particular shell script or just this snippet itself through ShellCheck, it'll tell you the same thing. And of course, not just for bash scripts, but really for any program files, always write a header explaining why the file exists, how it should be used, how the script behaves in both success and failure, and any return codes that the user might encounter when using or misusing the script. And speaking of return codes, you can use them in Bash just like with C and C++. So 0 is success, failure is non-zero. If you think your script is going to have multiple kinds of failures, you can use different codes for them. For example, you might use 1 for a missing file and 3 for a shimming toolbox module crash. And the return code won't be printed, but it is visible when the user runs this echo $question in the terminal, $question being a special variable for the status of the last executed command. And just as a hint, you can actually use this $question to catch a command failure inside your script as well. So maybe after you run a command, you want to make sure that it ran correctly. So in the line after the command runs in your script, you would have like an if double bracket $question equals not equals 0, then maybe you want to call some cleanup function. So that would be on the inside of the if clause. That code's unreachable if things go as planned, if everything's successful. So yeah. And I mentioned earlier that you should use double brackets for tests. And actually there are some really nice, convenient file tests in Bash that are built in for these some of these different states for files. So for example, you can check that a file exists. You can check if a file is readable. You can check if a file is executable. And there are many more examples at this link that I've included, which is a Bash cheat sheet and has lots of other nice tips and recipes for doing different things in Bash. So just generally, for writing Bash scripts, here's some other tips. Each script should do one thing well. A script that tries to do too many tasks will eventually fail at most of them as the rest of the code base changes, and it will be a pain in the ass to factor out its components. So keep it small. If the script starts getting to 100 lines, it's time to break it up into subscripts and call those from the master script. Definitely not sure if this would apply specifically to shimming toolbox, but your scripts should be composable. And what that means is that the output of one script can be usable as input by another script. In our case, we'll probably be handing around nifty files between some of the scripts. So using the pipe operator, you can pass output of one program into the input of another program. So that is definitely worthy of consideration. Also design and build your scripts so they can be tested quickly, although we do this all the time because we have CI/CD pipelines. And finally, I've said this already, but it's important, so I'll say it again. Scripts should fail loudly and they should succeed silently. You do not want your user to keep running scripts blissfully unaware that things are going wrong. So here are all the links that I've taken this material from. I really strongly encourage you to spend an hour and read all of them. If you found anything in this slideshow new, you heard something for the first time, I guarantee that in at least one of these links you will find other things that are new and that are useful for your workflow. So bookmark them, reopen them whenever you have to write more Bash scripts. And above all, practice with some toy examples in a dummy directory with some files that you're not afraid of overwriting. And yeah, that's my talk. So if you have any questions for me, you can message me and I'll try to find you an answer or at least find you a resource with an answer. Thanks.